Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! Thick fog is rising over the ocean as the sun is slowly sinking towards the horizon. It's hard to see further away than a few dozen feet, but that's enough to notice a hulking, skeletal shape in the distance. As your ship approaches the figure, your heart beats faster, and then you make out the details of another vessel, abandoned by the looks of it. Ghost ships do exist, and their mysteries aren't always solved. Take MV Hoita, for example. It was a wooden vessel built in 1931 as a luxury yacht. It had served well to various people over 20 years before it was bought by a Samoan sailor and became a merchant ship. In 1955, though, Hoita's service came to an abrupt and mysterious end. On October 3rd, it set sail for another trading voyage that should have taken no more than 48 hours. Delays happen in the sea, so when Hoita didn't arrive on October 5th as scheduled, there was little worry yet. But then it failed to come on the following day too. There was no distress signal or any other sign of Hoita's presence anywhere between its departure and arrival points. A search and rescue party was dispatched to find the ship, and for 6 days, they were scouting the area of nearly 100,000 square miles. On October 12th, the mission returned to the base empty-handed. Hoita vanished without a trace. It was only a month later that another merchant ship, Tuvalu, noticed the missing vessel far away from its route, drifting in the open sea and listing heavily. The sailors boarded the ship and found that all of its crew and passengers, 25 people total, were missing, along with all the cargo the vessel had been carrying. The radio was tuned to the International Distress Channel, meaning that the crew had been trying to ask for help, but they couldn't reach anyone because the radio cable had been damaged, limiting the range to 2 miles. The lifeboats were missing as well, indicating that people on board must have left the ship. Unfortunately, they seem to have taken the logbook with them, leaving the rescue team clueless as to what had happened. Even today, the mystery of MV Hoita hasn't been solved yet. No one knows where the crew and passengers had gone and what had caused them to leave. SV Carroll A Deering wasn't a ghost ship in the usual sense of the word. There were no sightings of it in the open sea. Instead, it was found on the shore, but the circumstances of it running aground are a puzzle shrouded in mystery. Carroll A Deering was built in 1919 in Maine, and it was a large vessel made for commercial voyages. Unfortunately, despite its large cost of construction, it had only served for a year before its last trip. July 19, 1920. The ship was traveling from Puerto Rico to Rio de Janeiro via Newport News to deliver a cargo of coal. It was almost halfway to the final destination when the captain fell seriously ill, and the crew turned back to drop him and his son off and replace the captain. The voyage went without incident, but when it came to Barbados in December to resupply, there were strange moods among the crew. The first mate didn't seem to be happy with the new captain. No one paid much attention to it back then, when they probably should have. The last sighting of Carroll A. Deering at sea was on January 28, 1921, when a lightship noticed it off the coast of North Carolina. There was some commotion on the quarterdeck of the ship, where the crew were normally not allowed. Then, another vessel sighted it, but there was already no one on the decks. On January 31st, the merchant ship was found hard aground in the Diamond Shoals, a site notorious for numerous shipwrecks that had been occupying there for centuries. When the search and rescue party boarded the ship, they found it abandoned, the log and personal belongings of the crew gone, along with the 2 lifeboats. There is still no answer to what happened on board of Carroll A. Deering that January, although the most popular version was mutiny. Maybe we'll never find out the truth though. SS Baychimo is perhaps one of the most notable ghost ships in history. This large cargo steamer was built in 1914 in Sweden and plodded its way dutifully over 16 years, trading provisions for pelts with native tribes of Alaska and Canada. But then, on October 1st, 1931, Baychimo got caught in pack ice. At first, it seemed the crew would be able to wait it out and continue on their route because the ship broke free in a couple of days. But in less than a week, it became caught again, this time for good. In another week, a rescue party was sent to fetch 22 of the Baychimo's crew, while another 15 remained behind to wait through the winter if necessary and get the ship back. But a month later, after a powerful blizzard struck their camp, the sailors went out of their shelters only to find the ship gone. Luckily, a few days later, a native hunter told them Baychimo hadn't been lost yet. He'd seen it about 45 miles from where they had been stationed. They managed to track it down, but decided the ship wouldn't survive the winter, so they took the most valuable cargo from its hold and abandoned it. They were wrong though. SS Baychimo did survive that winter, and many more that followed. When the ice broke, it sailed away on its own, drifting listlessly along the shores of Canada and Alaska. There were numerous sightings of the ghost ship, sometimes adrift in the open sea, and at other times stuck in the pack ice again. People attempted to board and salvage it, but weather conditions or lack of equipment always prevented them. SS Baychimo was last sighted by native Alaskans in 1969, 38 years after its abandonment. What became of it later remains unknown. The story of SS Ourang Medan is one of the most puzzling and harrowing ghost ship stories of the 20th century. No one even knows for sure if the ship even existed in the first place. It wasn't recorded in Lloyd's Shipping, the International Register of Ships, which makes it either a tall tale or a vessel that avoided being officially recognized for some shady reasons. In any case, the accounts as to what happened to the Medan vary. According to most reports, it was carrying some unknown cargo in the Indonesian waters when a distress call was received by another ship in the vicinity. The officer on duty heard an SOS message, but its contents are different depending on the accounts. The message did not repeat, and the crew of Medan didn't answer to any attempts to contact it back. The ship that received the distress call hurried to the rescue, but they only reached the vessel the following day, when it was already drifting and slightly listing. When the rescuers boarded the ship, they found that none of the crew had survived. However, one lifeboat was missing, which implied that there was at least one crew member who managed to escape. What happened to the rest of the people on board remains a mystery to this day. Still, there are no hard facts about this story, so we might never find out whether SS Ourang Medan was actually a ship and not a thing of fiction. SV Sebina was a 3-mast sailing barge built in 1873 for river trade ships in South America. She served for well over 4 decades, proving to be a sturdy and reliable ship. It was later transferred to Europe, where it continued serving its purpose well. But then, in October 1917, Sebina set sail on a regular voyage only to be found ashore several days later. Mysteriously, although the ship was perfectly intact, the entire crew of 5 and the captain were gone. There is no direct evidence or hard facts as to what really happened that day. The most convincing theory is that the crew were washed away from the deck because of an underwater explosion. And then the ship sailed ahead without them. But the truth, as always, remains unknown.
We've heard stories about people surviving in the desert, Amazon forest, and uninhabited islands for weeks. Such stories show how tough and resilient people can be. But among these many cases, there is one that can really amaze you. It's the story about a guy who spent 3 days inside a sunken ship at the bottom of the Atlantic Ocean. He didn't have oxygen tanks, electricity, communications, or food, but he survived. So, it all happened in 2013 on a tugboat that was moving through the Atlantic waters along the coast of Nigeria. That day, early in the morning, there was a small storm. The tug was pulling a vessel with oil tanks. Then, all of a sudden, a huge wave formed. It crashed into the ship and broke the cable. At 4:30 a.m., the tugboat turned upside down. Its entire deck was underwater, and the ship's hull stuck out from the surface. The boat began to sink slowly. The crew of 12 people were trapped, as they all were in their locked rooms. They had closed the doors in their cabins as a precaution, since there were many pirates in those waters. Because of the locked rooms, they couldn't get out. But one of them, cook Harrison Okina, was in the bathroom during this time. The bathroom turned over. Harrison fell on the ceiling. All the clothes and toilet shelves fell on his head. He was stunned and didn't understand what was happening. When he heard the screams of the other crew members, he realized that the ship was sinking. Harrison struggled to his feet. Holding onto the walls, he slowly went out of the cabin. The water level rose above his head. Harrison took a deep breath. He intuitively, driven by fear, reached the engineering room. There was a small pocket with air. This space wasn't wholly flooded, since the water didn't get there, and the air hadn't come out. Harrison realized that this was the safest place for him at that moment. He had no fresh water and no food. He was in a cold, damp room. The floor was flooded, and Harrison's feet began to freeze. There was almost no chance of survival. The man found a soda bottle inside the room and a life jacket with 2 flashlights attached to it. By this time, the ship had descended to the bottom of the ocean at a depth of 100 feet. This is about the height of a 10-story building. The ship's hull was squeezed and made a grinding noise due to the pressure of the water. Then, Harrison heard a strange movement outside the door. It was sharks and other fish that were investigating the deck. At this point, Harrison began to lose hope. Lack of food supplies and pressure weren't the main problems. The air pocket was small, which meant there was little oxygen. Every 24 hours, an average person consumes about 350 cubic feet of air, which means Harrison had less than 1 day left to breathe. But despite this, he lived in such conditions for about 60 hours. This happened thanks to the water. The pressure around the ship was so intense that it compressed the air by about 4 times. Another problem was the cook's breathing. When we inhale, we absorb oxygen. When we exhale, we release carbon dioxide. This substance is dangerous to your health if its concentration in the air is 5%. Harrison slowly filled the room with carbon dioxide, and he couldn't get out. With each hour, it became harder to breathe. But here again, he was lucky. Water absorbs carbon dioxide, and Harrison moved and splashed it in different directions. Thus, unknowingly, he increased the water area and kept the carbon dioxide level below critical. But even here, his dangers were not over. Hypothermia may occur in a dark, cold room. It's a condition when your body temperature drops below 95 degrees Fahrenheit. You get cold, and your perception of the world gets distorted. You don't understand where you are and what's going on. You may lose your memory and even experience terminal burrowing. This weird behavior occurs during hypothermia when a person tries to find a small shelter, even if they're in a closed room. They can even start digging the cold floor with their bare hands. At the same time, a person quickly freezes and loses consciousness within 2 hours. Harrison's room was filled from below with icy water. He wouldn't have survived in such conditions if he had stayed on the floor for several hours. But he managed to build a small platform with a mattress. This kept him slightly above the water level. With each passing hour, fear and despair more and more bound the survivor's mind. He couldn't get out for many reasons. One of them was that only a little sunlight passes to such a depth, and Harrison couldn't see it. The soda bottle was almost empty, and the flashlight stopped working. The man found himself in pitch darkness, but his salvation was close. While rescuers were searching for survivors nearby, he was thinking about his family and life. Harrison noticed rays of light through a hole in the wreckage. Divers were examining the seabed. It was the only chance to survive. Harrison came out of the air pocket and swam towards the rescuers. He was making his way through the darkness. The ray of light coming from the diver's flashlight disappeared. Harrison tried blindly to find the diver, but they were at the other end of the deck. His oxygen was running out, so Harrison decided to return. There was almost no air left in his lungs. He began to suffocate, but still got to the rescue room. The main thing was not to despair. It was his only chance for salvation. After catching his breath and replenishing the oxygen supply in his lungs, Harrison made a second attempt. He got out of the room and noticed the diver. He swam towards them with all of his might. The lifeguard didn't see Harrison, so the cook knocked on his neck from behind and grabbed his hand tightly. The diver was initially scared, but he realized a living person was in front of him. Harrison swam to his room and led the lifeguard as his oxygen ran out. You can easily find a recording from the diver's camera on the internet, where the frightened Harrison was in his rescue room during a meeting with the diver. The rescuers gave him an oxygen mask. They didn't believe there was a living person in front of them. Harrison couldn't immediately get to the surface because of the pressure. He spent about 60 hours on the seabed, so he needed to change the pressure level slowly to prevent damage to his health. Therefore, the divers put him in a decompression chamber to gradually reduce the external pressure. Then, when Harrison got out, he saw the stars. The cook thought that he had been at the bottom of the ocean all day, so he was surprised when he found out that he had been underwater for 60 hours. Also, he thought that all the crew members had forgotten about him and left the ship at the beginning. Many years have passed since then, but Harrison still has nightmares about his air room. Sometimes he wakes up in the middle of the night and tells his wife that the bed is sinking and they're now at sea. A similar case occurred in 1991 with scuba diver Michael Proudfoot. He was studying a sunken submarine off the coast of Baja California. During this dive, he accidentally broke his breathing regulator and deprived himself of oxygen reserves. Michael couldn't get to the surface because he was too deep. He wouldn't have had enough air in his lungs. Fortunately, the diver found an air pocket inside the ship. He swam there and waited for rescuers. For 2 days, he was underwater in complete darkness. He ate raw sea urchins and drank a small amount of warm water from a found pot. Fortunately, rescuers found him. Michael Proudfoot got out of the trap and stayed alive.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
In 1945, 5 TBF Avenger aircraft took flight for a routine training exercise around the Bermuda Triangle. In the middle of the exercise, the planes were struck by intense rain and heavy winds, despite the clear weather forecast. The pilots became extremely disoriented and radioed the base to report that their navigational equipment had stopped working. The last thing the base heard was, "When the first plane drops below 10 gallons, we'll all go down together," and then static. The 5 planes and their 14 crew members were never seen or heard from again. On his very first voyage to the New World in 1492, Christopher Columbus sailed through the Bermuda Triangle. Columbus reported that one night, when he was on the deck of the ship, he noticed a giant light appear in the distance, unlike anything he had ever seen before. Columbus looked at his compass for direction, and it gave off erratic readings. You might have noticed that the Bermuda Triangle doesn't appear on any world map. This is because official institutions refuse to acknowledge that the area actually exists. A popular theory suggests that rogue waves are responsible for the many disappearances. Rogue waves are called extreme storm waves by scientists. They occur when different weather patterns take place at the same time and cause large unexpected waves. Witnesses say that the waves look like giant walls of water. These waves could explain why ships go down fast and without leaving any trace. The Bermuda Triangle is home to some pretty intense and unexpected weather. Storms build up quickly and unexpectedly, then disappear soon after. If you blink, you might miss it. This could explain why few distress signals are issued. Pilots and sailors never saw the weather coming. No one knows exactly how many ships and planes have disappeared in the Bermuda Triangle. The rough estimate is 50 ships and 20 planes. Most of the time, the disappearances had no explanation and no wreckage has ever been left behind. Another bizarre theory trying to solve the Bermuda Triangle mystery comes from Charlie Berlitz. He insists that the area is home to the lost city of Atlantis. The missing ships and planes and malfunctioning equipment, according to him, were all caused by rays of energy let out by the special energy crystals that power Atlantis. While this sounds silly, Berlitz's theory was convincing enough that over 20 million people bought his book worldwide. In the year 1800, a large sailing vessel called the USS Pickering departed from the U.S. on its way to the West Indies. The ship sailed into the Bermuda Triangle along with its 90-man crew and was never heard from again. The USS Pickering was the first ever confirmed ship to vanish in the Bermuda Triangle. It's believed that the ship was taken out by a storm, but because no wreckage was ever found, we'll never know for sure. When the TBF Avenger planes went missing, a massive search operation was conducted. Boats and planes searched the Bermuda Triangle for any signs of the aircraft. One of the boats searching was a PBM-5 Mariner airboat. The airboat took flight at 7:27 p.m. and called in a routine radio message 3 minutes later. Then, it was never heard from again. No trace was ever found of the rescue airboat or the 5 Avenger aircraft. An enormous investigation was launched into the disappearance of all these vehicles, but nothing was ever discovered. This particular area of the ocean is one of the most heavily traveled shipping routes in the world. Some skeptics believe that this fact solves the mystery. Statistically, the busier the area, the higher the frequency of accidents and disappearances. While this makes sense, it's not the frequency of disappearances that's responsible for the mystery of the Bermuda Triangle. It's the lack of explanation or wreckage found. On the ocean floor, decomposing organisms let off large concentrations of methane gas that gets trapped under the water. This gas can build up until, boom, it ruptures. The gas surges up to the surface and erupts. If a ship was in the area of one of these ruptures, the water would become much less dense and cause the ship to sink rapidly and without warning. Scientists believe this could be the cause of the many disappearances in the Bermuda Triangle. While this theory makes a lot of sense, it doesn't seem too likely. The U.S. Geological Survey has stated that no large releases of gas are believed to have occurred in this area for the past 15,000 years. The ocean floor is made of rocks containing a lot of magnetite. It's more like iron. Magnetic fields react to high concentrations of magnetite on the ocean floor, which may start a sort of conflict between the two. It can often lead to various weather anomalies and, as a result, navigation issues. And, naturally, any changes in the ocean floor or the Earth's magnetic fields influence the Bermuda Triangle a lot. Since the magnetic field is constantly moving, it might be also taking the Bermuda Triangle with it. Now that people know where the triangle is, it's easy to avoid it. It supposedly moves eastward together with the magnetic poles, but scientists still can't answer where exactly it will be in a couple of years. Some people blame all the disasters on the extraterrestrial paranormal activity. Others suppose it's all about raging natural phenomena. There's another triangle in Lake Michigan. Just like the one near Bermuda, the Michigan Triangle got its shady reputation for some disappearances. The first recorded one dates back to 1679. A large vessel, one of the largest of that time, set out on an expedition. Yet once it got in the sinister triangle, it never came back. Much later, an aircraft disappeared in this triangle. The skies are usually very clear there, but back in 1883, some people witnessed abnormal things in the area. Some claim to have seen large blocks of ice falling from the skies, and the crew even managed to save one as hard proof. Meanwhile, the Pacific Ocean Mystery Area is another sinister triangle. Off the south coast of Japan, not far away from Tokyo, there's a sea where plenty of ships met their doom, disappearing without a trace in these waters. They call it the Devil's Triangle. Some scientists believe the cause of anomalies is the environmental changes. Also, there's a really high concentration of methane hydrates on the bottom of the ocean in the Pacific Triangle area. You're deviating from your original course and sailing in the wrong direction. There's the Caribbean Sea near the triangle, peppered with small islands. The seafloor here isn't deep. The ship can get in shallow waters. And now the ship is stuck on a shoal, and you have no idea where you are. If this were the 21st century, the ship's captain would be able to reach the shore using GPS and other modern navigation. But the most interesting thing is that the compass would work correctly this time, since the magnetic North Pole hasn't already coincided with the true one for a long time in the territory of the Bermuda Triangle. The agonic line is somewhere far away from here. There are no problems with navigation now, but for some reason, this is where ships disappear. In fact, not just here. Throughout the Atlantic Ocean, there are places where many more ships were gone. The Bermuda Triangle is not even in the top 10 of such places. One of the main reasons why many ships are lost here is that one of the most popular shipping routes in the Atlantic passes through the Bermuda Triangle. And the more ships in one place, the more shipwrecks. Simple probability. Then, it just starts getting weird. Other theories say that there's a space-time rift in this region. Ships and planes fall into this rift and end up in the past or the future. But for some reason, there's not a single proof of this myth. There's no reason to think that the rift is hidden somewhere here. The base of an extraterrestrial civilization is located in the Bermuda Triangle. Visitors from other galaxies steal sea vessels along with the crew, so no one finds the wreckage of the ships. This is also a popular myth that has no scientific justification. The Kraken lives somewhere in the triangle. It's a huge squid that sinks ships and also is a legend that sailors tell each other. However, gigantic squids live in the depths of the ocean. They can grow to the size of half a train car, but no cases have ever been recorded where they sunk a large vessel. And in the area of the Bermuda Triangle, they have never ever been seen. People in the past didn't know about the existence of these creatures, so when they saw them for the first time, they described them as huge, terrible monsters. Giant squids are some of the most elusive creatures on Earth, and scientists had to use sonar equipment to find them. They don't like to leave the dark depths and are likely to be afraid of the sound of any ship. So, that should squash the squid as a suspect.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas. speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Medan in 1984. Turns out, those tragic incidents were caused by something called Limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Medan and Nios in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An Anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metal workers use. Duh. The air from the Anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot Anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Moxstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future. The concept of oil on troubled waters may seem like a strange expression, but its meaning of calming a tense situation is well understood. The origins of this phrase, though, have a much more literal explanation. It's true that even the roughest waves can be subdued by simple oil. Just like you dress your salad with oil to make it nicer, you can dress the sea to make it calmer. At the end of the 19th century, captains from various ships shared their experiences of using oil to calm rough waves in letters to the New York Times. One of those captains, Olsen of the Norwegian bark Wilhelmine, detailed what he did to save his crew and ship during violent storms. Despite the challenges they faced, the oil trick proved to be a game changer, drying up the weather side of the deck and helping them navigate through heavy gales. His words hinted at a secret power hidden within these simple bags made of sailcloth filled with a regular animal oil. He used it several times, and each time, the technique worked like a charm. One time, his crew encountered heavy gales on their voyage to Belfast. They were causing quite a stir, but they managed to stay ahead of the game by deploying these bags made of sailcloth filled with animal oil. As soon as they released the bag from the cathead, the weather side of the deck dried up in no time, even as the seas continued to wash over it. It was pretty neat to see it working its magic without even needing to check if the bag was empty, as it was a real lifesaver. Their vessel was still a little shaky and taking on water on the lee side, but this little trick really helped them out. Captain Jenkins from the British steamer Francisco used a similar method to calm the seas during their voyage from Hull, England to Boston. They ran into some strong westerly gales, causing really big waves. They didn't want to head any further north, so they decided to stop the engines and chill for a bit. They stuffed some oakum into the pipes of the closets and filled them with oil, and it worked like magic. The sea calmed down along the side of the ship, the big waves disappeared, and they stayed nice and dry. In total, 12 masters shared their success stories of using oil against rough waves, with only one reporting that it didn't work as expected. The use of storm oil, as sailors called it, was a tried and true method of preserving crew, cargo, and livestock from the harsh sea conditions. The toughest thing some of them experienced was just a little spray. Their methods were a tad different, but all of them used oil. But what made this storm oil so effective? First off, let's clarify something. Storm oil is not your average supermarket olive oil. To be truly effective, storm oil must be made of that thick, next to water insoluble consistency. Technically, it acts like a surfactant. This practice is very old and has been used for many centuries. Since ancient times, people have poured oil to calm ocean waves. It was poured onto the ocean surface to reduce wave intensity, making it easier for sea rescuers and navigation. This spilled oil accumulates on the surface and creates a concentration gradient that leads to extra dissipation and damping as waves move. In the past, steamships and lifeboats from various countries were required to carry storm oil as this practice continued until the late 20th century. It was included in the United States Maritime Service Training Manual as essential equipment for lifeboats, and British vessels were mandated to have it until 1998. Often, vegetable oil or fish oil was used as a cost-effective option. While those options were commonly used as storm oil substitutes, the thick consistency was the key to the oil's effectiveness. Storm oil has a dampening effect on water, absorbing some energy from the waves. It quickly forms a thin layer over a large area of the water surface, preventing wind from creating waves easily. The use of oil to calm ocean waves dates back to ancient times, with Aristotle and Pliny the Elder discussing its effects. Benjamin Franklin famously studied the calming properties of oil on waves during his trips to England in the 18th century. Communication between Franklin, William Brownrigg, and Sir John Pringle led to further exploration of this phenomenon. Agnes Pockels also made significant contributions to the study of storm oils through her experiments in Germany. She suggested that the calming effect of oil on water involved more than just reducing surface tension. Oil is definitely a game changer when it comes to calming rough seas. But it's not just any oil that does the trick. You gotta use the right kind of oil and apply it the right way. Forget engine oil and other petroleum products, they won't do much. Fish oils are where it's at, especially the thick ones. The problem is, modern ships and boats don't really carry fish oils, so folks end up using engine oils and bunker oils instead. Not surprising that they don't see the calming effects they were hoping for. Back in the day, the Coast Guard used to carry a little tank of oil for rescue missions in choppy waters, but they stopped that practice ages ago. You can't just pour the oil on the water. You gotta let it leak out gradually, drop by drop. The best way is to hang a bag of cod liver oil or something like that over the side of the boat. The oil seeps out through the bag onto the water surface and smooths out the waves. Not only does the oil calm things down, but it also stops the wind from messing with the surface. Just a bit of the right oil, like a gallon or so, can flatten out a huge area around the boat. Believe it or not, tossing oil into the sea used to be allowed. Steamships and lifeboats were actually required to have equipment to slowly release oil during storms. The lifeboats on the Titanic fell under British law from 1894, which said they had to carry oil for bad weather. Now for the science part, as oil decreases water's surface tension, preventing those pesky waves from breaking. It's like adding an invisible layer over the water that makes it super smooth. So, when you pour some oil into water, the molecules don't clump up as they spread out to form a super thin layer. These oil molecules kind of do a somersault, standing on their heads and aligning with the water molecules like magnets. This creates a film on the water surface that is just one molecule thick. You can actually figure out the size of a single oil molecule by trying this out. For instance, one tester used a spoon that was under ½ an inch high, and the oil spot it spread out on the water was massive. If you do the math, you'll see that one molecule is incredibly tiny. Usually, wind creates waves by moving the surface of the water, but a layer of oil molecules acts as a barrier, stopping the wind from making waves and just pushing the oil around instead. This pretty cool trick has been used by all sorts of people throughout history for different reasons. I've already mentioned that Benjamin Franklin studied this phenomenon a lot, but he also liked to prank people by using this science. He would claim he could calm a choppy lake with just the touch of his cane. Turns out, he had a little vial of oil in the bottom of his cane that he could tap out onto the water surface. It made him look like some sort of magician or water-bending master. By the way, the science behind this trick is still used today. By putting a thin film of oil or smaller molecules like magnesium fluoride on glass, you can create invisible glass that reduces glare and reflection. This type of glass is used in smartphones, tablets, laptops, and glasses.